function here that's given. Unless they ask you to graph it, there's really no reason to graph it. It's a very much just a recipe.
Okay.
I know it says to sketch, so if you want us to, we can. The first thing you always find when you're doing these problems is delta x, which is b minus a over n. And you need to know the endpoints. So you cannot do this without knowing, what the endpoints are. And I guess they don't. So they say it's the region enclosed in the first quadrant. So you have to actually determine that, which is a bit more difficult. So you've just said 4x minus x cubed equal to 0, factor out an x, 4 minus x squared equals 0, x, 2 minus x, 2 plus x equals 0. So you find that it's from 0 to 2. Like, we don't know what happened, but it does something from 0 to 2.
Okay.
And then it actually does come back up, but you don't care about that because normally you're given, like, this would be A and this would be B.
Okay.
But in this case, no, you're not. They also don't tell you the number of subintervals, but when it says LRAM 4, that 4 is n, and that's how they get to this 1/2 here.
Okay.
So what I like to do is actually start at A and write A, whatever the value of A is, and then like increment it by this like 1/2. So one, plus 1/2, plus 1/2 again, you get 2 to 1, 3 halves, and then 2, wherever your B is there. And then depending on what we're doing, like, these are the values you need, like whether it's a left, a right, a mid, and so on. I'm going to just copy these numbers again here and try to use some colors to make it clear what's happening. So if you're doing a left uses these 4 numbers, and a right uses these 4 numbers.
Okay.
And a mid actually doesn't use any of them. The mid is generally the worst, because you have to produce midpoints between these. So you would use like 1/4, 3/4. Notice it goes up by 1/2, 5/4, and then 7/4. So this is what you're using for mid.
Okay. I think we did mid most of the time in class.
Oh boy, that's horrible.
Yeah. Well, I remember him asking, and people would always be like midpoint.
Okay.
I think they realized it was harder.
A typical question would ask you to do left, right, and mid, potentially.
Yeah.
On these. And then even trapezoid, I'm surprised you're doing trapezoidal rule. I didn't think that was covered. Maybe that's on the AP. But is this clear kind of how this is broken up?
Yeah.
Okay, so let's just say you wanted the left sum. The left sum is your delta x. So it's 1/2, but you always have this delta x on the outside. And then there's this formula, but it's f of 0, because of that 0 there, plus f of 1/2, plus f of 1, plus f of 3 halves.
Yeah, the whole long.
Yeah, and like, what this means is you're actually going back to that original function and you're evaluating it. So you're putting 0 in there, you're putting 1/2 in there, you're putting 1 in there, and so on.
Exactly.
And then right is a repeat of it, except you don't use that right. You do f of 1/2 plus f of 1 plus f of 3 halves plus f of 2. And then mid is, it's different. You don't get to reuse any of the values. 1/4 plus 3/4 plus 5/4 plus 7/4. So notice there's 1, 2, 3, 4 values, 1, 2, 3, 4 values, 1, 2, 3, 4 values, because the 4, like whether you're doing LRAM, MRAM, RRAM, it's always 4 values, 4 rectangles.
Just want to check the LRAM, RRAM, and MRAM. Those are each the left, right,
and mid. Yes.
So whichever one that they give us is the one we do.
Yeah. Yes, they have to tell you that. There's no way you can know that on your own.
Okay, good. I didn't know if they just like wanted us to pick one then.
Yeah, usually they specifically ask for one.
Okay.
So then the trapezoidal rule is a slight variation on this. It's got this formula. It's kind of horrible, but the trapezoidal rule actually uses all 5 points.
Okay.
So, but because they're trapezoids, it's again kind of a small variation. It's still that delta x. You take the leftmost values. In our case, that's 0. That's why I like to write the 5 numbers. But then you take 2 times each of the interior values. So f of 1/2 plus 2 times f of 1 plus 2 times f of 3/2. But the last point is like the first point. It's just by itself.
Okay.
And some instructors go into a heavy explanation of why that is.
Yeah.
You want to be able to do this without like looking at formulas, because I think the formulas are really unclear in some ways. I think it's better just to, it's like use pictures, like where do they overlap, or where's the mid?
Yeah. Instead of trying to memorize all the formulas.
Yes. If you truly understand this, you realize it's really just multiplying and adding. It's not even calculus in some ways.
Not that difficult. Yeah.
Yeah. This one's a little more difficult because it said like first quadrant. You had to know where it actually hit. And so is there anything else on that one? Like that's basically 1 through 5.
Yes. What
Just
are the
discussed.
1 through 5 questions? Let me check. Sketch R. Huh. Okay. So number 1 is just like what we did with the.
One is this sketch, but with more work done to figure out like how high it goes, but it's roughly this.
Okay.
And so then like depending on which left or right, like how big your rectangles are. Because it doesn't say, it just says sketch it into 4 subregions. So I think it just like wants you to come up and hit it.
Yeah. Like the paragraph.
Because but see if it's a left, let me go down here. Let me try to make this a little more visually appealing. So like let's pretend like this is 2 here. So let's just say it's like this. If it's left sums, it's hitting right there at the origin. So that first rectangle is there. And then that one looks like that. And then that one looks like that.
Yeah.
So on. But if it's right sum, you have you're hitting it. Let's see if I can copy this. Get rid of some of these, that. So if you're right, you hit it right there. So there actually is no rectangle there. The next one hits there and goes left. So it's a little odd. This is left and this is right.
Okay.
Right, you start from the right and then you go and hit it.
Okay. So
You
for
go.
one, they'd want us to draw both of those.
See, it doesn't say like which one, like these are actually, this is actually the sketch for number 2 and number 3.
Oh, okay. So they
Number-
probably mean like mid.
Yeah, I mean, it's unclear.
Okay. Okay. Yeah, I think I get it.
7 is a complete calculator problem. Have you been doing that at all on your calculator?
A little bit, but he also said that there's no calculators allowed on the test.
Okay.
I don't think that one's gonna be on.
Okay. So 6 says to find the exact area using the fundamental theorem of calculus.
Mm-hmm.
And I guess I don't know how much you know, because I never know where. It's kind of like, where are you at in the course
Yeah.
on this? The fundamental theorem of calculus is saying like, what is the integral from 0 to 2 4x minus x cubed dx?
Yeah.
Is that something you know how to do or not?
I recognize it, and we did
Okay.
with it. I'm not sure if I completely know how to do it.
Okay, let me just rewrite this because it's really horrible. 4x minus x cubed dx. So there's a first property which allows you to separate these integrals.
Mm-hmm.
minus the integral from 0 to 2 x cubed dx. And then if you need to, you can actually bring this 4 out if you want. So we'll do that. 4 integral 0 to 2
Yeah.
x dx
Give me one
minus.
second, sorry. Dad, I'm in the middle of a.
Okay, I'll be back in an hour.
Okay, bye. Sorry about that.
No problem. So there's one kind of integral rule that you need to know. It's the integral of x to the n dx. N is an exponent that is not -1. So long as n is not -1, this always equals x to the n plus 1 over n plus 1 plus c. This you have to know. This is like really important.
Okay.
It's fairly straightforward. You take this x to the 1 and you add 1 to it.
Okay.
And then you divide by the new exponent. So like whatever this is, which is x squared, it's a 2 on the bottom, and then you bring this 4 down.
Okay.
But because it's an indefinite interval, because it's a definite integral, we've got to evaluate from 0 to 2, which is kind of an extra piece. So if it didn't have these bounds, you would just write 4x squared over 2 plus c, but you're going from 0 to 2.
Yeah.
So we got to deal with that. This one's the same way, like you just add 1 to the exponent. So the new exponent is 4. That's why 4 goes on the bottom. But here you have to evaluate it from 0 to 2.
Yeah.
Is this something you've seen before?
Yeah.
Okay. All right. So it's worth simplifying a little bit before you evaluate the endpoints. So you got 2x squared evaluated from 0 to 2 minus 1/4 x to the 4th valued from 0 to 2. So it's always top minus bottom.
Okay.
So you put the top number in first. So it's 2 times 2 squared minus 2 times 0 squared. This all makes up this first part minus, and then we got to deal with this one over here. So we have 1/4 2 squared minus 1/4 0 squared. Oftentimes when you're putting 0 in, you just get 0. So like those go away. So that's 8. And then this is minus 1 because this is 0 plus 0 because distribute the negative in. So it ends up just being 7.
Okay.
And the idea is like those sums you just came up with over here in the previous part of the problem, they should be around this. Some should be smaller, some should be bigger, but roughly 7.
Okay.
Do you think you can replicate this process on your own for the exam?
Yeah.
Okay. Nine is your kind of your classic exam question. Is that where we'd like to go next? Where you'd like to go next?
Perfect.
Okay. So rather than answering the question as is, we're just going to look at each of these parts to try to see what they mean. So this says this is the area under the curve from -2 to 2 of this function f of x, which we don't have as 4. This one says from 2 to 5, same function as 3. And this one's a new function, g of x, it's 2. This is analogous to like questions earlier in the course when they said they didn't give you the function, but they just said f prime of 4 is 3 or g prime of 7 is -2.
Yeah.
Like they're just giving information without, like you're more comfortable working with a function that's like known like a polynomial, but you don't get that here. All right, so let's actually see if we can answer some questions here for this. Get rid of that. Okay, so part A is the integral from 5 to 2 f of x. So it's referring to this one right here. Okay, and there's this property that this equals negative of the integral 2 to 5 f of x dx. So basically when you switch the order of the bounds, you put a negative in front. So if it was negative, it becomes positive. If it was positive, it becomes negative. So this equals negative of whatever this number is, which is 3. And I think that's what it's asking for there.
Yeah.
So there's like, I don't know, 5 properties we'll say of these. Some of them we've already covered in the previous problem. So this one here, it says you got f of x, you got g of x. We kind of already looked at this. You can, it's like applying the distributive property in some ways. You can do the integral from -2 to 5 f of x dx. It's almost like that's distributing in, plus the integral from -2 to 5 g of x dx.
Yeah.
And then you look at your if you got it out, you scroll back up, but I believe this one is, what is this? Oh, this one on the right is given, that's 2. Now this is another property here. This one, you can split apart the bounds or combine them. So let me snip this in. I think this will be clear. So this first one is, what it really is the sum of these. It's the going from -2 to 2 f of x dx plus 2 to 5. So see how like there's a path here, -2 to 2 and a path from 2 to 5.
Yeah.
That's what this first one's saying, like, oh, you can add up like the individual parts to make the whole.
Yeah.
So this is 4 plus 3 plus 2, which is 9. I think that's what it's asking for.
Okay.
Part C here. Part C, it says f of x is less than or equal to g of x on the interval. This one, a little bit harder for me to say anything about because to be clear, it's not talking like, I wish it was doing this, is like this we could actually answer.
Yeah.
But I don't know what f of x is. I just know that the area under the curve, you only know something about the area under the curve. This is what you know. This right here refers to, like, let me try and show you graphically what this refers to. It refers to, here's f of x and here's g of x.
Okay.
It's just below it. And we have no idea. We actually have no way to know that. Like, because remember, it could be that like it gets all of its from -2 to 2. It could get all of its area and then like be a little bit negative.
Yeah.
And that's how it gets to be 7. Now the area is, so this area was 7 and this area was 2. So if we were doing the integral, but again, all that means is that there's more area under the curve. It could be that this was f of x. I don't know. G of x could do, it could be way up here and then have a lot of area underneath down here. We have no way of knowing. So I'm not really sure how to answer C based on what's here, but
Okay.
I would say we can't actually decide that.
Okay.
So maybe if you want to ask a question, that would be
Okay.
all right.
Got it.
Is 12 on your list?
Yeah.
Okay, I got to look up these never come back again until except in this part of the course.
Hmm.
Some of them are going to be very straightforward, like A,
Yeah.
and B, but I'm unclear about like E. If
Yeah.
so let me just do a quick search here. All right, well, I'm not finding what I want.
Okay, well, we can skip that one.
Let me just provide just a one or two, and then we'll move on to the next one. So what yeah, let's move past this. This never comes up again besides this part of the course. So
Okay. Would
We
it be
can-
possible to just do like A?
yeah, so so the short of it is that the sigma becomes integral, ck becomes your x, and this goes for x cubed dx. But you've got to get the right bounds, and that's I mean, I see. I'm fairly confident is this right here, 0 to 10 x cubed dx.
Mhm.
But there's some things you can actually do to kind of like move around where this starts, but I don't think any of these do that. Yeah, like x ck k sub interval c sub 1 cubed over n. Yeah, and so like b would be the integral again. So wherever you see a ck, that's your x sine x dx from 0 to 10. But you're supposed to do it this way. You're actually supposed to write out the limit as n goes to infinity. Let me do that for part A. Sigma k equals 1 to n ck cubed delta x.
Okay.
And that equals the integral from 0 to 10 x cubed dx. So this is what your instructor is looking for part A.
Okay. So just rewriting it. Basically.
Yeah, just rewriting it. There's a bit more to it, but I think that's enough. These are really hard to find because they're so unused. And I'm just looking for a sample problem to like refresh, because of course this never happens in yeah.
Well, yeah. Okay. I can figure it out. I've got the
Okay.
gist of it, so.
Okay, so let's move on to it looks like some problems from 15 to 31. Is that right?
It's
Every
every
other
other odd.
Okay.
From 15 to 31.
All right, so these are much more straightforward. And this is what you're going to see kind of for the rest of the class, stuff like this.
Yeah.
All right, so 15. Okay, whenever you have a constant, you can bring it out. You won't do this forever, but this is really 5 integral minus 2 to 2 dx. And then this part right here, without the 5, it just becomes x. So the integral dx equals x. It's whatever, the integral is paired with this dx, and then the result of this particular one is just x. And that 5 comes down, and then you evaluate it from minus 2 to 2. It's always top minus bottom. So it's 5, 2 minus 2. You're putting that 2 in for x, negative 2 in for x. So 5 times 4, which is 20. And just for a geometrical interpretation here, that 5 corresponds to 2, 3, 4, 5. Y equals 5. And you're going from minus 2 to 2. So it's just this area.
Oh, okay.
It's the rectangle. It's base times height. All right, so every other odd would put us at 19.
Yep.
All right, so the variable of integration can be anything, doesn't have to be x. You can change it to x if you really don't like it. But this is 3 separate integrals. It's 0 to 1, 8s cubed ds minus integral 0 to 1, 12s squared ds plus integral 0 to 1, 5 ds.
Okay.
And then you can bring the numbers out if you want. 8 integral 0 to 1 s cubed ds minus 12 integral 0 to 1 s squared ds plus 5, guess you that one out, integral 0 to 1 ds.
Okay.
And again, like here, we already talked about this property, but each of the other ones are just what's called the power rule integral. So it's, you bring the 8 down, so you add 1 to the exponent, s to the 4th, divide by the new exponent, and then you evaluate it from 0 to 1. Minus 12, here you add 1, divide by the new exponent, okay, plus 5, and then we just did one like this where you put an s, 0 to 1.
Okay.
And then I'm going to simplify here before we evaluate. 4s to the 4th minus 12, I'm sorry, 4s cubed plus 5s. Now the truth, a couple of things here. The truth is that you can actually just evaluate the whole thing from 0 to 1.
Okay.
Okay. And the other one is that whenever you have a polynomial, the 0 is always, the 0 bound, whenever it's 0, it's always 0 for a polynomial. And
Okay.
some others, but like you start seeing these trends and they're actually true. So this is like 4 times 1 to the 4th minus 4 times 1 cubed plus 5 times 1. That's all of this is your top, by the way, minus, and whatever you do bottom, I like to put it in parentheses, 4 0 to the 4th minus 4 0 cubed plus 5 times 0. And this is your bottom.
Okay.
So you have to add up, you subtract whatever the bottom is, but it's in parentheses. In this case, it's 0. So you get 4 minus 4 plus 5 minus, and this is all 0. So just 5.
Okay. Yeah, that makes sense.
Okay. There's an entire table of integrals. Did your instructor give you one? Do you have one in your book?
No. There
Okay.
might be one in my book, but our instructor, we kind of have a rough situation instructor wise right now because my teacher quit last
Oh.
semester. So we have a long-term sub.
I see.
And he's not the best at explaining things.
Yeah. Well, maybe.
He kind of just rants.
Okay.
a
a lot of TikTok videos on that right now. Teachers ranting.
Yeah. He will explain like these simple problems for like the entire hour class period.
Yeah, that's not gonna help you much. Let me just send you one here by chat. And this is just one that I like. You're welcome to find. There's infinite number of these in the course. But if you go to let me send this to you by the chat. So it used to be that before the internet, like there was books, people would print books of all the there's thousands, infinite numbers of these integrals, but like a sheet is kind of nice to have even now. And this is on page 2. I'll snip. So the ones that you need to know, I think mostly are in the common integral section. I'll just snip that in real quick. We've already talked about a bunch of the ones up here, but this one comes from right down here. And yeah, you do need to memorize these. So you can't go further in this course if you don't spend some time learning these. Like you don't need to know that one or that one. You will know how to do them at some point, but and these these come later in the course, some of these other ones, but it's kind of like the 80-20 Pareto stuff. Like you need to know 80% of this if you want to do well.
Yeah.
So this one is, and if you just like, okay, I know this is tangent theta, evaluate it from 0 to pi over 3.
Yeah.
So it becomes tangent pi over 3 minus tangent of 0. So you got to know your unit circle, pi over 3 on the unit circle is up here. If you remember that point. So sine is square root of 3 over 2. And cosine is 1/2. Tangent 0, 0. So just as a kind of a related question here, they can sort of make some of them look deceptive. Like they can say on an exam, they could say, what is the integral 1 over cosecant of t dt? And you're supposed to remember that, oh yeah, that's sine t. And you can do the one on the right, but you can't do the one on the left until you transform it.
Okay.
It's just warning you on that. Do we do 30? Do we do 29? I can't remember.
Yes.
Okay.
Wait. 15, 19, 23. No, 27.
27.
And then we do 31.
Then 31. Okay. All right. Yeah. So again, like if you have this table, okay, it's this one right here is 31.
Okay.
Now it's you could do the following, like and I think this is what the way this is intended. You could, no, I'm sorry, it's not. It does want you to go from these horrible bounds. So it's secant x evaluated from minus pi over 3 to 0. So that's secant of 0 minus secant of minus pi over 3. So this is really 1 over cosine of 0 minus 1 over cosine minus pi over 3. So on our unit circle, minus pi over 3 is here.
Mm-hmm.
So it kind of maps well to that one that's up there. So its point is 1/2 comma minus square root of 3 over 2. And if you know that, then you can quickly evaluate this. So the x value there is 1/2. So it becomes 1 minus 2.
Okay. That's good.
All right, 31. You said it's next. So these say to use formulas from geometry, and what's encoded in that is like you have to be able to graph these. You want to like first graph, which could be easy or hard depending on a lot of things. Then you draw vertical lines at the endpoints. And that creates this boundary or this region that you're going to find the area under. So square root of x, I'm sorry, absolute value of x, you know that looks like a V. And not to scale here. I guess I can do okay here. There's minus 4. Using a nice triangle, and then 8. We'll just count here. 1, 2, 3, 4, 5, 6, 7, 8. One more. So you can break this up into like region 1 and region 2. And the area of a triangle is 1/2 base times height. The other ones that come up are rectangles and then even circles, which we haven't seen yet, but a circle I can show you after this example. So the one on the left here is 1/2 base of 4, height of 4. The height can always come from here. Like if you put -4 into the absolute value of -4, you get 4. I think this one's clear, but like, let's say it was the absolute value of like, I don't know, 6x minus 12. Like you might want to actually put the point in to see what your height is.
Yeah.
And then on the right here, the base is 8 and the height is also 8.
Yeah.
So you got 8 plus 32, you got 40 for that.
Okay.
So just really quickly here on circles, x squared plus y squared equals r squared is a circle of radius r centered at the origin. You've seen that before.
Mm-hmm.
If you solve it for y, you get y equals square root r squared minus x squared. And then I'll just give you a few examples here. Let's say it's the square root of 4 minus x squared. This is a radius equals 2 circle centered at the origin. And here's why it's important is I might ask you, instructor might ask you for this from 0 to 2. So from 0 to 2, our circle looks like this, but we only want this part. So it's a quarter circle. And if I change it to minus 2 to 2, then it's the whole thing.
Okay.
And the area of a circle is pi r squared. So if it's half a circle, you obviously want half of that. But it has this form, and it's totally reasonable to ask you to do that in this part of the course.
Okay. Okay. Makes sense.
We're doing 34.
Let's double check. Yeah.
34. Okay. This is an AP style question that you're going to see potentially on the exam. Are you planning to take the AP?
I'm not.
Okay. Then this will not appear for you. So this one's a bit vague because it says upper and lower estimate, and you're used to left sum and right sum.
Not up and down.
Yeah. And so one of these is too big and one of them is too small. You will, when you do the calculation, you will determine which one is too big and too small, because one will be smaller than the other or larger than the other.
Yeah.
But recall the formula, right? You're taking your delta x, which is encoded in this 3-second intervals. It's also the distance. It's also the difference here. That's your delta x.
Mm-hmm.
It's 3. So you have to know that. So to do your left sum, it's 3. Okay. And then remember how we like this is x and this is f of x, or t and f of t.
Mm-hmm.
It's 5.3. Okay, is your speed. Okay,
Yeah.
plus 5.25 plus 5.04 plus on and on and on here, plus 1.11.
Okay.
But you stop there. Remember the left, you stop at the last one.
Mm-hmm.
And then the right is 3, but you don't include the first one. So it's 5.25 plus 5.04 plus 4.71 plus dot, 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 1.11 plus 0.
Okay.
And one of these will be bigger, one will be smaller.
Mm-hmm.
Now you have to have a calculator to do this.
Yeah.
Well, not, I mean, maybe not, but like you said, no calculator in this.
Yeah.
So you're probably not gonna have this question.
Probably not. Or if
But
we do simple numbers.
yeah, it'd be nice numbers. And you would have to do this. Is again, like I know I asked you for, like, is this clear? Could you replicate this?
Yeah.
Do you see where, like don't include one? So now part B is
Quick
go
question.
ahead. Yep.
Would the left or right be considered the upper, or which would be the lower?
Okay, so see how the one on the left does not include 0,
Yeah.
but the one on the right does.
Yeah.
So 0, like you're comparing 0 and 5.3.
Yeah.
Because everything else is the same. So the left in this case is going to be the bigger because that 5.3 contributes where 0 doesn't. In this case, the right is the smaller, but it's not always that way. It's like if 0 were here and 5.3 were here, then the left would be smaller.
Okay. So typically whichever one is the bigger one is the upper?
Yep. Like, yep.
Okay. So it could either be left or right.
Could be either one.
Depends on the problem. Okay.
Yeah. And this right here is the same in both. So you're literally just comparing these two values to a side.
So whichever one has the larger one.
Yes.
The upper. Okay. Perfect.
All right. Now trapezoidal rule here is next, to estimate the distance. So it's just a new formula. your trapezoidal rule is your delta x, which is 3 times, and then it's 5.3 plus, but then it's 2 times each of these. So let me actually snip that. That'll be easier to do here. Let me go over this down here. So it's your trapezoidal rule is 2 times 5.3, sorry, 3 times 5.3. That's your delta x,
Mhm.
plus 2 times, it's 2 times each of these in the middle.
Okay.
So it's 2 times 5.25 plus 2 times 5.04 plus 2 times 4.71 and so on. 2 times 1.11, but the endpoint is just by itself. It's just 0.
Yeah.
So what some students do or some instructors show is it's 5.3. I like this, plus 0. Those are the 2 endpoints.
Mhm.
And then it's plus 2 parentheses. And then you add up all these middle ones, 5.25 plus 5.04 plus 4.71 and so on.
Okay.
Because it's only the endpoints that get counted once. The interior ones get double counted, which is okay. It's just the nature of this.
Yeah. Okay. Yeah, that one makes sense.
Okay, 30, 40, 40, 54, 40, 54.
Yeah.
These are did you know there's a fundamental theorem of like algebra? Did you know that?
No.
Okay. The fundamental theorem of calculus, this is one of them. It's not all that exciting.
Don't
So
worry.
there's step.
Excited.
Well, you kind of are waiting for this like big reveal, and you're like, that's it. It's very disappointing.
It's the big theorem of calculus.
Yeah, you're like, oh, I'm gonna finally like I'm at the mountaintop. It's like, nope, it's really not all that interesting.
Not that exciting. The view's
Okay.
not great.
So for this problem, it says to find dy dx, which is a little bit odd. You're like, wait, we've got integrals. I'm done with that part of calculus.
Yeah.
But there's steps here. So the steps are to put the upper bound into the function.
Okay.
So in this case, you're gonna take this 7x squared and you're gonna put it in there. If it doesn't have an upper bound, like in 41, see how 41, it has a lower bound that's a variable. You actually have to manipulate it, but we'll go off the assumption that this is gonna be like your exam question.
Okay.
The second thing you do is you multiply by the derivative of the upper bound.
Okay.
So the answer, so dy dx, and this is the notation your instructor wants to use, is the square root of 2 plus cosine cubed 7x squared. Okay, and then you multiply out here, it's like chain rule, derivative of the upper bound.
Okay.
And that's it.
Okay.
The second part is most often forgotten. And sometimes you don't need it. Like in 39, the upper bound is x. So the derivative of x is 1. Multiplying by 1 doesn't do anything to change it.
Okay.
42 has a variation on this. But like, I don't know how much, we only use, you only asked for 40.
Yeah, that's fine.
So we'll go with that.
Oh.
54, on to 54. Right. All right, so they're giving you a graph. This is a circle. That's kind of what I was mentioning here. This time it has a radius of 2, but it's centered at -1. This right here is a triangle. That's a line potentially. So they want you to find various things here. So let me snip these in one at a time. So g of 1 here, what this means, and if you're going off of this notation here, it wants you to find the integral from 1 to 1, because x is now 1, x goes in that upper bound. And they just use t instead of x, but that's the variable is irrelevant. Sometimes it's even called a dummy variable. Have you
Yeah.
heard that? So f of t dt, and this is a property. Whenever the upper bound matches the lower bound, upper bound equals the lower bound, this always equals 0. Doesn't matter what's inside here, it's always 0.
Okay.
Okay, so now we'll move on to part B. So part B is to find g of 3, which is the integral from 1 to 3, f of t dt. This means the area under the curve, area under curve from 1 to 3. Now it is below the curve, and we do consider that. So this is a triangle with base 2, that's 3 minus 1. It's got a height of 1. So in terms of like finding area, you treat the area as if it's a shape, that because shapes only have positive areas. But then you decide, well, if it's below the x-axis, it's negative.
Yeah. Okay.
All right, part C is to find g of -1. So this is the integral from 1 to -1, f of t dt. You want the leftmost bound to be on the bottom. So I would change this to negative integral -1 to 1. So whenever you flip the upper and lower bounds, you negate it.
Yeah.
So the area from -1 to 1 is this part of this circle. You grab it here. So it's this area right here, which is a quarter circle. So the area of a quarter circle is pi r squared divided by 4. Okay, and these are like not related. Like the integral of this is not this on the right, but this is the geometric area on the right.
Yeah.
So you're not evaluating the bounds or anything.
Mm-mm.
So your radius is 2, so it's pi 2 squared over 4, which is just pi. But because there's a negative in front, your answer has to also be negative.
Okay. Okay.
That does take us to the end of our lesson today.
No problem.
If you need a short question to answer, just connect with me on Instagram, Twitter, Facebook. I'd be happy to answer you there.
Okay.
And appreciate you scheduling. I'll see you next time. Good luck on your exam.
Thank you so much. Have a good day.
You too. Bye now.